All right. Question 26. Ray deposited $5,000 into an investment account, earning 3% per annum, compounding quarterly. Now, this question here has a bit of a trick just by looking at the answers. I'm going to be very careful with how we approach this question. So, the way I see it is that we want to turn this into some sort of recursion relation. So, we're going to come up with Rn is equal to VO times R to the power of n in this case. So, if we've got VO, Rn is equal to 5,000 times rate, and we're going to go 3 divided by the quarters. So we're going to go 3 divided by 4 divided by 100 plus 1. Okay, and so this means that our R value is this, which is 1.0075. Okay, so 1.0075. Now the problem with this is that generally the question ends by saying after n compounding periods. So in this case, it would usually match up. But you can see this one here, quarterly and years, doesn't match up, which means that we need to almost convert this quarterly into years, because this is at the moment n quarters. And there's 4 quarters in a year, which means that really technically the answer is Rn is equal to 5,000 times 1.0075 to the power of 4n, because that's what 1 year would be. So 2 years would be 8 quarters, 3 years would be 12 quarters. All right, if we look at the next question. Okay, so 20 years ago, Hector invested a sum of money invested in this after 10 years. Okay, so in doing these sorts of questions, I can tell immediately this is a two-step sort of approach that we need to take. Now, the reason why this is a two-step approach is because there's one condition here and there's another condition here on the second part. So the way I would do this is first, I would draw up 2 tables. Okay, and the reason why I'm going to draw up 2 tables is because I'm going to see what it's like with the first condition and how that changes the second condition's values. Okay, so the way I'm going to do this now is read through the question. 20 years ago, Hector invested a sum of money earning the interest rate of 3.2% per annum compounding monthly. After 10 years, he made a one-off extra payment of $10,000 to the account. For the next 10 years, the account earned an interest rate of 2.8% per annum compound monthly. The balance of his account today is 686,904.09. So I'm going to put this in my current future value. So 686,904.09, because that's what he's finishing up with. Now I'm going to put it as a positive value because it's an investment and he will be paid that particular amount. Now, the payments, we don't know yet. PPY looks like it's compounding monthly and compounding monthly. So 12, 12. Okay. Now, the interest rate is 2.8% for the second part. And it says for the next 10 years. So this is going to be 10 times 12. And so, he made a... Okay, it doesn't look like he made any extra payments. So in this case, payments will be 0. So if we look at this situation here, we're going to just fill in the extra information from the other side. So total, 20 years. It looks like it's 10 times 12 here as well. And it's 3.2%. And the payments will be 0. But if we look at this, okay, this yellow bit right here, the future value, the present value of the second part depends on the future value of the first part, which means that if we work out that yellow bit from here, we can use that answer to transfer that there, and we can use that to work out the answer for our blue bit. So let's do that. Okay, so if we go, all right, so let's plug the values in. We've got 120, 2.8. What we're trying to work out is the PV. Our PMT is 0, and our future value is 686,904.09. Okay, if we use this to work out our present value, we get 519. Yeah, that number. So we get 519, 320.30. Now that was a negative value that appeared here. So when we plug that back into the yellow component, we're going to make sure that we turn that into a positive 519, 320.30. However, before we move on to the next step, this is a crucial payment. This is a essential thing right here. It says after 10 years, he made a one-off extra payment of $10,000 to the account. So in other words, um, the payment, the final balance, the future value after 10 years is not actually 519,320. It's actually 509,320. Okay. So we had to make sure that we subtracted this from our future value. And we're going to just go back to TVM solver now to plug in all the rest of these values. So we can copy and paste this value. So if you highlight, Control C, we get rid of this, and we go Control B, and we go 30, we go backspace, and we change this to 3.2. Okay, but we've got to make sure that we subtract the 10,000 from here, and then we get a present value of 369,999.99, which is closest to B in this case. So you get 369,999.99, and it's B. All right. Next question. Okay, so this next question says a least squares regression line as such is fitted for an explanatory and a response variable. The standard deviation is twice of the response variable. 81% of the variation in the response can be explained by the variation in this. Correlation between this and this is negative. The residual that's associated with the data point, this. Holy moly. Okay, let's try and work out this question step by step. I just want to get this one out of the way. I see 81% of the response variable variation responsible can be explained by the variation in the explanatory variable. That tells me that 0.81 is my r squared value, and hence my r value is equal to 0.9. Now it says that the correlation is negative, which means my r value is negative 0.9. Now, we essentially need to work out what's the equation for y is equal to a plus bx by hand. So we need to draw on two formulas. We need to do linear regression by hand, and the formulas that are associated with finding a and b are as follows. And then it will be the gradient is equal to b is equal to r sy over sx, and the a value is equal to the mean of y minus whatever b is times the mean of x. Okay, let's keep going from here. It says that the standard deviation of the explanatory variable is twice that of the response variable data. So that means S x is equal to 2 times sy. Because 2 times the response will give you this. Okay, all right. So now we can use this information to work out b. Because we've got b is equal to, what was the r value that we calculated? 0.91 or 0.9 times sy. What was sy? Sx. So we'll say sy over 2sy Okay, the SYs can cross out, which gives us a B value of negative 0.45 if you divide that through on the CAS. So if you run this through on the CAS, you'll get B is equal to negative 0.45. Now from here, we can plug that into that formula. But this one's a little bit difficult because we're so used to using the mean and the the mean of x and y that we forget that we can also use the data points to help us work out the equation line. So this is a bit of a stretch of a question, but let's try it out. So we can then say we can work out a with just normal y minus negative 0.45 times um, x. And what was our x value that we were given? We said we could use 2 and we could use 5. So a is equal to um, 5 minus negative 0.45 times it with 2. A is equal to, oh my, I just realized with this question here, I was just about to sub in 5 and go through my process, but I have to remember this point is not 2, 5. This point here is the actual data point. So the actual theoretical point is 2, comma, actual minus predicted is 5.5. So my actual coordinate based on theory is 2, 5.5. So it's actual minus predicted. Oh, sorry, other way around. Actual minus predicted. So that means this is the actual value. My predicted value is this. And if the residual value is this, it means that my actual was more than my predicted. So that's why my point is 4.5. Wow. So this one here goes 4.5 minus negative 0.45 times 2, and that's 4.5 plus 0.9, which gives us 5.4. So 5.4 is our A equation. So what does that mean? It means we've got y equals 5.4 subtract 0.45x. That's our regression equation. Now, if that's our regression equation, now we can plug in 3 into the regression equation. So we get y is equal to 5.4 minus 0.45 times 3. And you can probably see my shame of using 5.9 there. You'll probably, if you did this question and got it wrong, you probably know why. All right, so let's try this out. 5.4 minus 0.45 times 3. And we get our actual predicted value is 4.05. So our actual value is 4.05, but so my predicted value is 4.05, but what's my actual value? 4. So if we go actual minus predicted to find the residual, we get 4 minus 4.05, we get negative 0.05. This is a really, 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 really tough question for a one marker. The fact that you have to, it's a very multi-layered question where first you have to find the regression equation, and then from the regression equation find the residual. And that part right there is very sneaky as well. All right, let's move on to the next question. Now, next question says, the environmental researcher believes that the possum's conservation status is associated with their habitats. Okay, so that means when we're talking about some sort of association, I like to draw some sort of chart here. And I don't know which one's the explanatory response. So status, habitat, and then we've got habitat, and then status. Okay, so when I usually see these questions, I like to think, okay, how does this chart or what does this relationship look like? And depending on whatever the data is, because there's missing information in this question, I would then have a look at Does the data go that way? Does it go that way? Does it have some sort of spread out or sporadic um, distribution? Now, that's one way that I would read this question. I just realized the other way that you could read this question is by having a two-way sort of. So if this is categorical, we've got two categories. So this is if it's two numerical variables. Okay. By looking at this question, it doesn't look like they're numerical variables. It looks like they might be some sort of bar chart related, or even some segmented bar chart related, where they've got something here. The key thing that you got to remember with these sort of questions, if they're categorical, association for numericals depends on the strength of the R value. And also, it's the linearity aspect. Okay, so if it's linear, um, we can assume that we can use the R value, but also the variables have to be both numerical. Otherwise, we can't have a scatter plot. Now, if it was a chart where it looks like this, or if you've got a percentages, like sometimes I've seen exam questions where they've got percentages and they say yes, no, in group A and group B, and this is like say 60%, and this is 40%, and this is 60%. Terrible numbers actually. Let's say 20%, 80%, and this is 40%. And the question is there an association with the group and the decision made? Well, key word here is difference. If there is a difference, if there is a significant difference, there is an association between the two variables. Now, the follow-up question you might be asking is, what's the actual threshold for difference? It's a gray area. Maker will probably make it very obvious, like, for example, if there's a 10% difference, 20% difference. In this case, it's very subjective in terms of, I guess, sample size or whatever the context is. But if there is a difference, there is an association. So there's two types of questions that you might receive this from. I'd probably say this one here looks like it's categorical, so it'll probably fall into that realm. All right, and the last question that I'd like to do is relating to matrices. So we've got a matrix question here. So it says, consider the following system of linear equations, and we've got some sort of equation that we're trying to solve. Okay, so what I would first do is I want to first understand that my natural matrix system is solved by doing AX is equal to B. And at the end of the day, I want to get my X by itself. So if you do AX B here, the way we can eliminate this A on the left-hand side is by using the inverse. And so if I do the inverse to the left, I need to make sure I balance it out with the inverse on the right. But I have to make sure the position is also the same position as well. This will give me X is equal to A inverse times B. Now the question that you have to work out is, what's A inverse? Well, the first thing is, what's A? Well, let's dissect that from this information that we've got here. So I'm going to set it up so that it looks like there's three variables. So it's going to be a 3 by 3 matrix. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to set up my X matrix, which has my three letters, X, Y, Z. And I'm going to set up my equals matrix so that it's 4, 1, 2. So let's set up the numbers now that we have for this question. So how many X's do I have, Y's, and Z's? So the X will be 0, the Y's will be 1, and the Z will be 1. Okay, same thing with the next one. Z, Y, X, Y, Z. So X is 1, Y is -1, Z is 1. And the last one, my X is -1, my Y is 1, my Z is 0. So, in order to solve this, we've got our A value now. You just need to go and plug this into the CAS and type in this to the power of -1. And you'll be able to work out what the correct alternative is. So let's do that now. So let's go as 3. We've got 0, 1, 1, 1, negative 1, 1, negative 1, 1, 0. And we'll raise it to negative 1. And we get that. So that means which one is closest? So 1, negative 1, negative 2. But it has to be on the left-hand side. 1, negative 1, negative 2. It must be E in this case.